For tonight's Conversations with Great Minds, I'm very pleased to be joined by British ethologist and evolutionary biologist Professor Richard Dawkins. He's a scientist and author whose life work has educated millions and challenged the popular beliefs of a generation. Professor Dawkins is best known for the ideas laid out in his landmark book, The Selfish Gene, and developed further in The Extended Phenotype, which is the radical notion that Darwinian selection happens not at the level of the individual, but at the level of our DNA, and implies that humans evolved for only one purpose: to serve our genes. He's also equally well known for his criticism of creationism and intelligent design. He's an atheist and humanist, and a vice president of the British Humanist Association and supporter of the Brights movement. Professor Dawkins has become a leading figure of new atheism. The English language version of his groundbreaking book, The God Delusion, where he argues that a supernatural creator almost certainly does not exist and that religious faith is a delusion, has sold more than 2 million copies and been translated into more than 30 languages. He is an emeritus fellow at the University of Oxford and founder of the Richard Dawkins Foundation for Reason and Science. He joins me now from our studios in Miami. Professor Dawkins, welcome.
It's a pleasure.
Thank you. It's a pleasure and an honor to have you with us. In The Selfish Gene, you shook up the discussion of natural selection. You coined the term the selfish gene as a way, correct me if I have this wrong, please, as a way of expressing the gene-centered view of evolution as opposed to the views focused on group selection. Given that you also say that genes just are, that they can't survive independently of the cell can't survive independent of the organism, how do you reconcile the need for biological cooperation with your hypothesis of a selfish gene?
Cooperation takes place at the level of the individual. Individuals cooperate. Genes are selfish. The whole point about my book, The Selfish Gene, is not that individuals are selfish, but individuals may very well be altruistic and cooperative as a result of their genes being selfish. And obviously that takes a book to explain, but it does not mean that individuals are selfish, still less that they should be selfish.
Point taken, and a good point. I'm curious about the genes being selfish, the individual genes themselves. You said it would take a book to explain. We have actually 20 some odd minutes here to talk. Can you explain your reasoning on this?
Yeah, well, obviously genes, they're only made of DNA, so they can't actually be selfish in the same sense as we are. They don't actually have motives, they're not conscious, they don't think. But a gene that causes individuals to behave in such a way as to foster the welfare of that gene will survive. And so it's the self-interest of the gene in that sort of metaphorical sense that I mean. What you will not get is natural selection favoring a gene that sacrifices itself for the benefit of other genes. But you may very well get an individual that sacrifices itself for the benefit of other individuals.
Wouldn't that willingness to sacrifice yourself for other individuals be gene-driven behavior?
Yes, it would. And that's the point, that a gene that makes an individual sacrifice itself, the individual self, for the benefit of the gene will survive. And that would often mean for the benefit of copies of the gene in other individuals, notably close relatives.
Right. So in other words, our altruistic impulses, the desire not to be selfish, but to care for family, for friends, for community, and to sacrifice for them, actually perpetuates our genes even if we don't produce offspring, because those genes are also appearing in others of our local family.
That's correct, yes.
Okay. Genes aren't static. They'll express various alleles in response to the environment around them. Spontaneous development of celiac disease in response to food poisoning, for example, is, I think, a pretty good example. So how does that entire concept of an interactive phenotype fit into your theory?
What you're talking about there is the expression of genes, so that the genes that are in you may or may not express themselves, and whether they express themselves may depend upon the environment, may depend upon your food, may depend upon your age, and so on. So the genes themselves are just in you, and they may or may not get passed on to your offspring, but how they express themselves will depend very much on the environment, notably by the other genes that happen to share the body with them.
And not just in an individual organ or cell or close area, but more broadly.
Yes.
Yes. Okay. And also it would be their interaction with other genetic material. For example, my understanding is that more than half of the total DNA in our body is not human genes. It's all the viruses and bacteria and fungi and other things.
Well, that's true. I mean, that's very interesting. And yes, interaction with the bacteria, for example, in our gut, which are massively numerous in our gut. And even within every one of our cells, the mitochondria, which are these vital little organelles that are responsible for giving us energy, they were once upon a time bacteria, and they reproduce by the same means as bacteria do reproduce, as an entirely independent population inside our cells, and they get passed on in the egg to the next generation.
Yeah, so at some point in the past, cells were infected by bacteria, and thus began the evolutionary process that led to mitochondria in cells.
In the very remote past, yes.
Yeah, I'm curious if in your work you've come across anything that might indicate that phages are the super small, for our viewers, the super small viruses that infect only bacteria rather than an entire. If they have played a role in modifying the genes of bacteria that we then interact with and that may in fact modify our genes. Is there any evidence of that?
Very probably. Yes, very, very probably. Bacteria are rather different from us in that bacteria are constantly swapping genetic material, rather like we with our computers copy and paste bits of text from one document into another. Bacteria are constantly swapping, exchanging, copying and pasting genetic material into other bacteria. And viruses, phages, play a role in that, yes.
Yeah. I've had, over the years, a number of political discussions, which is typically the topic of my programs, other than this segment, and had objectivists in particular, people who are followers of Ayn Rand, actually quote you and suggest that your selfish gene metaphor and the economics of Milton Friedman or Friedrich von Hayek and the modern libertarian movement are the same thing, and that your selfish gene movement or your selfish gene hypothesis, assertion, you'll have to fill in the word. I'm sorry, I don't have the correct word. Informs that, not informs that movement, but demonstrates the validity of individual selfishness. I'm curious how you would respond to those people. I'm sure you've heard
I would disavow and disown that. One of the most surprising things that happened after The Selfish Gene was published was that I started getting letters from right-wing libertarians in America. I'd never even met a right-wing libertarian, but they started writing to me. It's a total misunderstanding. As I said before, genes are selfish, and that's nothing to do with whether individuals are selfish, or rather it's a very complicated relationship. And in particular, it says nothing whatever about the moral rightness or wrongness of being selfish. You can take a stand on that, which is based upon something quite different from my stand on evolutionary biology. There's no reason why somebody shouldn't read The Selfish Gene and, as it happens, be a right-wing libertarian, but absolutely there's no reason why they should read The Selfish Gene and therefore become a right-wing libertarian. I have always voted on the left in British elections.
That's interesting. I'm curious your thoughts on the relationship between genetics and political worldview. There's been a fair amount of speculation and writing in recent months about the genetics, or at least the neurobiology, of politics, of political worldview. How do you think that whole dance plays out at the level of genes?
Well, I mean, one's political opinions, like everything else about one's views about everything, are governed by one's brain. And brains are, of course, built by genes interacting with each other and with the environment in the processes of embryology. So there are doubtless genetically influenced differences in brains which affect political opinions, but it's going to be very complicated. And I would hesitate to say anything in detail about that.
Yeah, just so it would be more like there's no gene for race, there are just genes for all these various characteristics. There is no gene for being a conservative or a liberal. There are genes that might give people certain proclivities that would cause them to draw toward one or the other?
That's right. Yes, in very complicated interaction with other genes and with upbringing, education, and so on.
Right. You write and talk a lot, and I apologize, I've only read 2 of your books, but I've read pieces of many others and a lot of commentary over the years. You write and talk a lot about the classical concept of gradual Darwinian evolution. I'm curious, and my apologies if you've already dealt with this in one of your books and I just missed it, about your thoughts on Stephen Jay Gould's concept of punctuated equilibrium as an enhancement to Darwin, the concept that evolution really, macroevolution, species evolution, is not generally this slow, gradual process, but rather there are periodic disasters that happen that wipe out 90+% of an individual group, and the small subset of that group that is most adapted to the new environment, even though they may have been maladapted to the earlier environment, are the ones that continue to survive, and maybe even that accounts for gaps in the fossil record. I'm curious your thoughts on that whole thing.
Well, what you've just outlined is not really punctuated equilibrium, although you could be forgiven for thinking that, because punctuated equilibrium was expressed in such a confused way that anybody would be forgiven for muddling up at least 3 different things. What you just described is the phenomenon of mass extinction, which is indeed very important. Every 20 or 30 million years or so, you may get a mass extinction, and then occasionally you get a very, very large mass extinction. And after that, in a sense, evolution kind of starts all over again. So when the dinosaurs went extinct 65 million years ago, the mammals, which up to then had been rather small bit players in the drama, suddenly flourished because the dinosaurs had gone, and gave rise to all the great diversity of mammals that we see today. Now that pattern of periodic mass extinctions followed by a new flowering of evolutionary diversity, that is undoubtedly true. That happens. That is not punctuated equilibrium. Punctuated equilibrium is the idea that there are, if you follow the evolution of any one lineage through the fossil record, you may see long periods of stasis when nothing very much happens. They stay pretty much the way they are. And then suddenly there's a jump to a rather different form. Now, even that is confused. It's confusing because it muddles up 2 different things. It muddles up one idea, which is that there really is a sudden leap in evolution, a macro mutation. A child is born of a different species from its parents. That's one possible interpretation, which I think is wrong. The other possible interpretation is that evolution has been going on, but very rapidly, during the time when, as it were, paleontologists aren't looking, during the time when fossils are not being laid down. Perhaps the fossils are being laid down in a different geographical area. So if you dig in any one place, you don't see the change. What you see is what looks like a sudden change, because animals that have been evolving in a different area suddenly re-migrate into the area where you're digging. So that looks like a sudden jump. Now that's perfectly plausible. That probably happens. That probably does account for some of the apparent gaps in the fossil record. But I do deprecate the use of the phrase punctuated equilibrium, because from the very start, from Eldridge and Gould's initial introduction of it, it has been confused, not least by Eldridge and Gould themselves.
Oh, very interesting. Yeah, it's been 20 years or more since I read Gould, so thank you for correcting me on this. We will get back. I'd like to get back to, or not back to. I'd like to get to a conversation of religion and spirituality and some of the other issues that you tackled in some of your other books in just a moment. First, we have to take a break for a second. More conversations with great minds with Richard Dawkins when we come back in just a moment. Your new book, The Magic of Reality, How We Know It's Really True, and some of your other works on the God delusion, for example. You were well, actually, let me go to the magic of reality first. This is just a beautifully illustrated book and makes science so accessible to basically people of any age. You asked the first question of the first chapter, what is reality? What is magic? Is almost an existential question. You want to take a whack at that?
Well, this is a book designed for young people primarily, but actually for all ages. And I'm trying to make the point that magic, as in the sense of supernatural magic, magic spells, as in fairy tales and miracles and Harry Potter and things, that reality, real science, where there aren't any miracles, is much more exciting and much more magical in the good sense of the sort of poetic magic, when we say it's magical looking up at the Milky Way at night, that kind of thing. So I'm trying to show that myths can be fun, and there are plenty of myths in the book, but science is better. Science is more interesting, more fascinating, more enthralling, and that takes reality seriously. We don't have miracles, we don't have supernatural spells, we don't have magic in that sense. What we have is reality, which is magical, is wonderful, and we study it by the methods of science.
And speaking of reality and magic, and I would put probably most religions in the category of magic, or perhaps you do. In the UK, you have religious fundamentalists, but they're largely politically marginalized. Here in the United States, basically the religious fundamentalists have become a portal through which candidates for the presidency must pass, particularly on the Republican side. Do you think this may have something to do with your country having had the experience of religious zealots like Cromwell and Guy Fawkes, whereas here they've never created a full-out theocracy?
It's very difficult to know. It's a curious anomaly, because if you look worldwide, religion is pretty much a third world problem. Religion goes with lack of education, goes with poverty, it goes with despair. And I mean, that's why in Western Europe religion is dying, all except for the Muslims, but in Christendom, in Western Europe, Christendom, religion is dying because of prosperity and everything that one would think that America has, and indeed does have. And yet half of America, very nearly half, is not only religious, but preposterously so. I mean, 40% of the American electorate actually believe that the world is only 6,000 years old, or less than 10,000 years old, which is a quite ludicrous error. It's not a slight error, it's a massive error. And this is something which stands out like a sore thumb. I mean, you expect to find that in Islamic countries, and you do. You expect to find that in Iran, Pakistan, Afghanistan and so on. You do not expect to find it in the richest and most highly educated country in the world. But I think you possibly can get a clue to it by noticing that those parts of the United States which are most influenced by this kind of fundamentalism tend to be those parts that are less well educated, that are less prosperous, less looked after, and so there might be a tendency for people who have who don't have a very nice life for one reason or another to turn to religion as a kind of refuge. And that's one theory that I've heard advanced. There are others. I mean, another theory is that because the United States has a constitution in which church and state is very rigidly separated, unlike in Western Europe, where many countries, including Britain, have an established church. And because we have an established church, it's been argued, religion has become sort of boring. A church is a place you go to be married and to be buried, but otherwise you don't go to church. But in America, where there is a constitutional separation between church and state, perhaps this has freed up religion to become free enterprise and to use all the sort of tricks of capitalism, of advertising and so on. And that may be why it's taken such a hold of the less educated classes in America.
And not only that, we give them complete tax breaks. So you end up with
tax breaks are just shocking. I mean, yeah. Yes, indeed.
Yeah, so you end up with people like Pat Robertson, who's a billionaire with a B as a result of this. I'm curious if our genes are controlling our behavior. And many people have had experiences that they would describe as deeply spiritual, and thus maybe draw them to religion. Why would such a gene echo down through the generations?
Well, it's a difficult thing to say that genes control us. We are very much influenced by our education, by our environment. So I'm not sure that I would want to ask that in a sort of genetic way. It's probably true, as we said earlier on in our conversation. I mean, genes do influence brains, and brains are what decide whether you're going to be religious or not. And so there might be a genetic component in whether you are, in whether you tend to be drawn to religion. Now, you mentioned the word spiritual, and that's a much misused word, because people often use spiritual to mean the kind of thing that I mean by the magic of reality, the kind of thing I mean by looking up at the stars and being filled with wonder, being filled with joy at seeing the stupendous sight of the universe, or looking down a microscope, or thinking, or going to the Grand Canyon and looking down through the layers of geological time. I mean, that's magical in the sense of the magic of reality, and you could even call that spiritual. But I rather resent the hijacking of that. Call it spiritual if you like, I prefer not to. I rather resent the hijacking of that feeling, which I feel, and which any of my scientist friends feel, hijacking by religion. It is not a monopoly of religion. We all feel it, or we all are capable of feeling it.
This is the human condition. Very well said. In the God delusion, you're asserting that a supernatural creator doesn't exist, and that belief in a personal God qualifies as a delusion. Do you also make that argument for the belief in any sort of consciousness beyond the individual? For example, could it be that the universe itself is a conscious organism and we're one expression of it within it? Or for that matter, what is consciousness?
Well, I don't know what consciousness is, and it's a very difficult philosophical question. I don't think it's probably going to be helpful to talk about the universe as a whole being conscious. I know that some rather mystical philosophers have suggested something like that. I think that whatever consciousness is, it's manifested by brains. It's something to do with brains, or the functional equivalent of brains. I mean, I wouldn't rule out that one day somebody might build an electronic computer which was programmed in such a way that it was conscious. That seems to me to be actually quite likely. But it comes from very, very complex organization, such as the brain, which is an extremely complicated organization of billions of neurons. And if anybody makes a computer that's conscious, that again will be extremely complicated with many, many, many units, electronic units. So no, I don't think it's helpful to think that consciousness resides in the universe as a whole. I think consciousness is something that emerges by the evolutionary process in the universe, wherever in the universe brains, or something functionally equivalent to brains, emerge, evolve.
Do you think it's conceivable that as the internet and the number of computers connected to it begins to approach numbers that are similar to the number of axons and ganglions and synapses in the brain, that the internet itself may, you said consciousness emerges from it, that consciousness may emerge from the internet?
That is a fascinating science fiction speculation, and before we laugh it away, we should remember that that's pretty much what did happen in the evolution of brains, because brains started off as very simple nervous systems, and then the simple nervous systems got bigger and bigger and bigger, more and more interconnected in complicated ways, and that is what's happening to the internet. And so I wouldn't absolutely rule out the possibility that sometime in the future something like the internet, probably very different from the way the internet is now, but something like the internet, a global network of electronic connections between computing devices all over the world, might develop something like the same properties as the brain evolved millions of years ago.
It would be quite remarkable to one day turn your computer on and have it say, Well, hello there, Professor. How was your tea this morning?
I'm sure that's already possible. I'm sure that's already possible.
But I mean, with intent,
but it would be a bit of a trick. It would be a bit of a fake.
But with worldwide intent. Back to your book, The Magic of Reality. We have just 2 minutes left here, and I want to be sure to. You ask a number of great questions in here. Who was the first person, for example?
Well, yes. I mean, that's chapter 2 of the book. Every chapter in the book is a question like that.
Yes.
And every chapter begins with myths and then goes into the science. So who really was the first person? Well, there never really was a first person, because every animal ever born was of the same species as its parents. And so there never was a first Homo sapiens born to a Homo erectus parent. It all happened gradually. But if you stick together enough generations going back into the past, then you'll find a gradual turning into apes and monkeys and shrews and going back to fish and beyond. So we are descended from fish. But every single creature that was ever born is of the same species, was of the same species as its parents. The process is so gradual, rather like the movement of the hour hand of your watch. You can't see it move, but if you wait long enough, you see that it has moved.
Professor, it's extraordinary. We have just only 30 seconds left. The main message that you would want our viewers to know about your work.
I'm passionate about the truth, and the truth can be ascertained by science, by evidence. Never believe anything until you've seen the evidence.
That's brilliant. Professor Richard Dawkins, thank you so very much.
Thank you very much.